Hello friends, today we are going to discuss about an example on the topic block diagram reduction techniques. The techniques or the tricks I have told you in my previous video. You can check the techniques. I am giving the link in the description. You can check and revise the techniques. You can write down in your copy and practice it more and more, and after that the reduction technique, the block diagram reduction, will become very easy to you. Now here I am taking a question or a problem, and I am going to reduce this block diagram into a single transfer function. Find out the transfer function using block diagram reduction technique. Here the input is R and output is C. This R is actually RS, means the Laplace transform of input, and this C is actually CS, the transfer function, the Laplace transform of the output. Hence the transfer function, finally it will become output by input, means CS by RS when all initial conditions are 0, means when we will reduce this block diagram into a single transfer function, that transfer function will be CS by RS. Now let us reduce this block diagram first. Now in this case we have to do it in some steps, and we have to use the previous techniques which we have learned, and this way it will be reduced. Now you can pause the screen and think the ways in which this can be reduced. There can be many ways, but finally the transfer function which will be the result, that will be same in every technique, in every case. So I am taking in a way, it can be a good way to reduce this one. This is an easy problem. I will be explaining a more important problem in case of exam point of view, and that will help you. Now here the first step it will be easier to reduce this block diagram when I shift this takeoff point after G3, because if I take it after G3, these two can be multiplied and feedback calculation will be easier. So to take this feedback or this takeoff point after this block, we have to divide G3 from H2. Now we have to draw every step, so I am drawing the first step. This will be as before, and these are the adders, or we can say a summer. This will be as previous, means no change, and here after that G2, G3 will come, and this takeoff point will become after it, and here will be now 3 takeoff points. This will go to this summer like before. The second takeoff point will go to this as a feedback. Now here in this path we see that there is no value given, means no H1, no H2, or no H3. So this feedback value is 1. This feedback value is 1. Every time when there is no transfer function gain value given, you take it as 1, means here the feedback is unity. This is unity feedback, and this will be as before. Here it is also a unity feedback. Why this is feedback? Because the input is output flow is this way, and in the feedback path it is given to this adder. Hence this is feedback and the value is 1. Hence this is unity feedback. Now in the next step we can reduce this and we can write the multiplied value of both of them. So let me write it first. This will be as before, plus minus, this is negative feedback, here it is also negative feedback. Now these two value will be multiplied. You know the rules, you have seen before how this is coming. So here the 3 takeoff points will be there. Very easy. This is a very easy problem. In case of unity feedback, you don't need to write 1 every time. You assume it and you can solve it easily. If you practice a lot of time, a lot of problems, it will be easier. Now, in takeoff points, we can shift it before and after, and no change in the block diagram will be there. Means this takeoff point, I can take it here. I can take it here. In that case, it will start from here and the feedback will be in this path. Means if I calculate this part, the overall transfer function will be, as there is negative feedback, the overall transfer function will be G2 by G3 by 1 plus G2 G3. Now in my next step I can draw it plus minus, as there is negative feedback, plus plus, here is positive feedback, then G1 and the calculated overall transfer function of this part, and there the simple output. Sorry, I forgot to divide H2 by G3. Now G3 is there, G3 is there, and here it will be H2 by G3. Now this is correct. In the next part, these two transfer functions will be multiplied and then I will calculate the positive feedback, and in case this will become G1, G2, G3 by 1 plus G2, G3, and when I calculate the overall feedback, then I will take this as feedback and this as the system transfer function or the plant. Then the overall transfer function will be like G1, G2, G3 by 1 plus G2, G3, and as there is positive feedback, then 1 minus. This is very important. Don't mistake here. When there is positive feedback, 1 minus H2 by G3 into this G1, G2, G3, 1 plus G2, G3, and if there is negative feedback, this will be plus. Now calculate it. This we can do in rough. Don't need to show here, you just need to show here where you are drawing the block diagram. You can do it in rough. Then the calculated value, let me find it, g1 g2 g3 by 1 plus g2 g3, and if I calculate it, then this portion will go above g3 into 1 plus g2 g3. Now this is calculated. Now I can emit this part, and the rest will be g1 g2 g3 multiplied with g3. In this portion I can take common the g3, and then it will become g3 into 1 plus g2 g3 minus g1 g2 into h2. g3 g3 will be cancelled, and this will become g1 g2 g3 by 1 plus g2 g3 minus g1 g2 h2. And finally this calculated value will be replaced in this part, and now we can draw it as R. Input is going, this adder will be like as before, and now this plane transfer function will be g1 g2 g3 by 1 plus g2 g3 minus g1 g2 h2, and then there will be the output and the only unity feedback. This calculation is left. So this calculation is very easy when there is unity feedback, like this will be g1 g2 g3 by 1 plus g2 g3 minus g1 g2 h2 by 1, as there is negative feedback, 1 plus 1 into this portion. If we calculate it, it will be resulting as g1 g2 g3 by 1 plus g2 g3 minus g1 g2 h2 plus g1 g2 g3. This is very easy calculation, you can do it, and it will be practiced by yourself. You can practice it and see that this is coming or not. So now there will be the output and here will be the input, means the transfer function of the system will be transfer function Cs by Rs is equal to g1 g2 g3, this same portion. And this will be the answer. Now you see that if we practice the block diagram reduction techniques, all the tricks, you can easily understand how to calculate the overall transfer function. Now this was an easy problem, so practice, and if you practice a lot, you see a problem and you can find the smallest way to solve it, because there is a very huge and complicated ways can be possible, but you have to do it in the shortest time. So practice more, practice a large number of problems.